Good day. I have a request from both Aiden as well as Andrew from Palmerston North, and they want me to try and solve this problem, which is an excellence question. The question is, prove that the difference between the squares of any two consecutive integers is equal to the sum of these integers. It sounds very mouthful, but it will only take you like less than 5 minutes to solve this excellence question. So we let the two integers, okay, let the two integers be x or n, and the next one had to be n plus 1. Because it is 4, the next one is 5, so it becomes 4 plus 1. If it is 8, the next number is 9, so if 8, then become 8 plus 1. So the two integers are n and n plus 1, okay? So, they said the difference between the squares of any two consecutive integers, okay? So the square of the two integers, so the n is going to be n squared, okay? Plus the second integer, the difference is that the bigger integer is going to be n plus 1 squared, okay, minus the first integer is n squared, and that is equal to the sum of this integer. The sum means you're going to add n plus 1. So that is the first integer, second integer, okay? So they said the difference between the squares of two consecutive integers, so the difference, they take the bigger integer minus the smaller integer square, okay, is equal to the sum of this integer. Okay, if you can prove that this is equal to this, then you're done. So we are going to simplify the one on the right side. So n plus 1 is going to be 2n plus 1. Okay. On the left hand side, we're going to expand the n plus 1. So use your grid, it's going to be n squared plus 2n plus 1. Please check the answers for me, okay? And on the second expression, it's going to be just minus n squared. So we're going to continue. So n squared plus 2n plus 1, we take out the bracket, minus n squared, and you cancel the n squared, is equal to 2n plus 1, and that is an easy excellent, and you do it in less than 5 minutes. In fact, I did it according to my video, it's only 2 minutes and 20 seconds. So that is an excellence. Hopefully, you are able to do this type of proving question, and I'll see you in the next one. Cheers everyone, have a great day.